For the next lab, we're going to do a reaction, and we're going to monitor the stoichiometry of the reaction. This reaction is unusual because it produces a gas, and so we're learning how to handle gases in stoichiometry. So our goal is, when we conduct this reaction, when we react magnesium metal with hydrochloric acid, to be able to collect the gas that's made and calculate the percent yield that we actually get. When you come into lab, I want you to have drawn down the reaction, including the product, so that you know what gas we're collecting. And I want you to have thought about what the theoretical yield is, so that you're ready to calculate the percent yield at the end. Also, make sure that you have a drawing of the reaction setup, which I'm about to show you, and you have a data table drawn out that has spaces for all the little pieces of data that you're going to need to collect. If you do that, you'll be prepared for the lab. So this is essentially our reaction setup. You're going to need a chunk of magnesium. There's no exact length. The recommendation is about 2 centimeters long, so about that long. And of course you want to record the mass of it exactly. It is going to be the limiting reagent. We're going to have an excess of hydrochloric acid. The hydrochloric acid is 2 molar. It's extremely strong. So you need to be very careful with it. If it gets on your hands, just wash them off, but you'll probably feel some itchiness. So those are our 2 reactants. And the way we set this reaction up is not that complicated, but it involves the setup with a, this may look like a burette, but the ones that you'll have in class will have a closed glass end, and we call them eudiometer tubes. So you're going to need a eudiometer tube, a big beaker of water, a ring stand, and a clamp. And then we'll show you how to get it set up. To get the reaction going, essentially what we need to do is we need to stick our magnesium in the hydrochloric acid in a way that will allow the bubbles to go up inside of our tube. The tube's going to hang upside down in this ring clamp. It's going to be full of water, and we're going to set it in the beaker. So let's see how we do that. Well, first thing to do is to get your magnesium ready. The magnesium, we can't just stuff it up in the tube, it's going to fall out. So what we're going to do is we're going to use a bit of copper wire to kind of wrap a cage around it to hold it. So I might fold it in half like that, and there's no magical way to do this, but I'm going to just keep wrapping the copper wire around and around and around. So maybe like that, where the copper is being held by the magnesium is being held by the copper wire. It'd be better if I had the cage all the way around the magnesium, because we don't want it to fall out. But that's the general idea. So the copper is just there to hold it. And if you're wondering, does copper react with magnesium? The answer is no. Or with hydrochloric acid? The answer is no. The copper should be there in the end. Now, let's see. So we're going to stick it up in there like this, and we'll have the tube full of hydrochloric acid. So the way we're going to do that is, first let's fill the tube with some water. And actually I'm going to use this stopper also to sort of hold on to the copper wire. So it'll go stuffed up in there like that. And you'll notice there's a hole in the end of the stopper to allow some water to come out. And that's how it's going to be held. Now let's put some hydrochloric acid in there. Now the trick with the hydrochloric acid is, you got to remember that if we just pour hydrochloric acid into our burette, at some point I'm going to have to hold my finger on the end here and turn it over into the water to invert it. Now I don't want 2 molar hydrochloric acid on my finger, so it would be best if the hydrochloric acid were down here at the bottom half. So I'm going to fill that part with HCl. It would be a really good idea if you used a funnel. So I'm going to pour about half the tube full of hydrochloric acid. It doesn't matter how much, because the hydrochloric acid is going to be in excess. Oops, I have it open. Your tube will not have an opening, hopefully, and so you don't have to worry about that. Mine's not quite half full because I leaked some out, so let's add a little more. Ugh, I'm making a mess. All right, there you go, about half full. And then, so the hydrochloric acid is down at the bottom. I'm going to fill the top half very carefully with a little bit of water. Now, I'm going to do it from the sink. On lab day, I may have some squirt bottles, and you can just gently squirt it down the side, because our goal is to not mix the two. All right, so hopefully the bottom half has hydrochloric acid in it, the top half has water in it, and they haven't mixed too much. You notice it's completely full all the way to the top. You don't want any air bubbles in there. I have one little air bubble. I should really get that out of there. You'll do a better job. And then I'm going to turn it over. My finger is not burning because the hydrochloric acid is on top, but the HCl is starting to come down. Well, wait a minute, I forgot one more thing. We got to put our copper in there. Oh, darn it, I let an air bubble in. That's not too bad, though. So right like that, I'm going to hold my finger over the hole to keep it from leaking, and then I'm going to turn it over into the beaker. That was actually a pretty good job. And when you do this in lab, you're going to be able to see the little swirls as the hydrochloric acid starts falling down. And eventually, it'll go all the way down until it runs into the magnesium, and the reaction will start. You should see vigorous bubbling. So we'll see in a minute if that happens. So we should see vigorous bubbling. And we're going to let this go until all the magnesium is gone. So there the bubbles are kicking all the water out, and it's filling up with our gas. It'll probably only take about 10 minutes to be done. Alright, so our reaction's done, all the magnesium's gone, our tube is full of gas, and we need to measure all of our gas law quantities, pressure, volume, and temperature. So in order to do this, we could just read the volume directly off of the burette, but we have to make one little change before we do that. So this is the part where you got to be really careful. You'll notice that we're going to use atmospheric pressure. Remember, just like in the last gas law lab where I brought the pressure to you, we're going to do the same thing here. Now, the problem is the pressure inside the tube is not the same as the pressure outside the tube. And we need it to be like that. So if you're really, really lucky, you can fix it. You notice right now the liquid level inside the tube is much higher than the liquid level outside the tube. But you notice I cannot lower it down far enough to get the two at the same level. And I can't record the volume unless they are at the same level. So my solution here is I need a taller container. This one will work great, hopefully, we'll see. And so I'm going to transfer it from there to there. Now if I pull it out, all the water is going to go gushing out. So I need to very carefully cover the hole on the bottom with my finger. Now my problem is the copper wire is sticking out of there. So I'm actually going to pull, am going to pull out the stopper and stick my finger on the end. There we go. And so as long as I'm careful, you notice the water doesn't leak out, the volume didn't change, it's fine. So Mrs. Jones is going to assist me by putting more water in my graduated cylinder, and hopefully you have a reliable lab partner as well. All right, there we go. Oh, I did it without letting any more air in there. All right, so now we can do it. We have a container that's deep enough that we can push it down. I'm going to push it down until the two liquid levels are perfectly even like that. Now the pressure inside and the pressure outside is the same, and I can record the volume using the graduations on the side of the burette. This is really, really important to make sure that you have the liquid levels even. And you may have to problem solve like we just did.